Alrighty, let's see. This is Algebra 2 lecture for 1014 and 1015, OSA 211 again. Student will solve quadratic equations by factoring. In this case, we're going to do very much things that are very similar to what we've done last time, but we're going to notice that the coefficient of the quadratic term, that's the number in front of x squared or m squared, whatever your variable is not going to be a 1. So I'm going to show you one technique to deal with that, and there's another one that we'll do later. So here we go. We're going to solve these by factoring. And as we did last time, we want to set one side equal to 0. So I'm going to turn this side equal to 0 because I want my quadratic term to stay positive. So I'm going to add 77x to both sides. Whoops. 77x, not just 7. That turns that into a 0. I'm going to add 196 to both sides, and that turns that into 0. And I have to add 77x plus 196 on this side. And when I rewrite this, I'm going to put it in standard form, the quadratic term 7x squared plus 77x plus 196. That's all equal to, and this whole side turned into 0. So here we have a quadratic equation that's set equal to 0, and my first number in front of my quadratic term, that's called the coefficient of the quadratic term, is not a 1. So what I'm going to try to do is factor a 7 out of all of these if I can. And in today's problems, I'll be able to every single time. If I can't do that, we'll use another method, which is the T method, which we've already covered. But we're going to use factor. We always try to factor first if we can. And I see that this will divide by 7, so that's 7 times x squared, plus, if I divide this by 7, I pull a 7 out, that'll leave me 11x. Plus, and if I divide 196 by 7, what will that be? 7 goes into that twice with a remainder of 5, so that would be 8. I believe that's correct. Equals 0, and I'm going to use my handy dandy pocket brain to make sure I haven't made an error there. 196 divided by 7 equals 28, yay. All right, and now we're going to try to factor this quadratic trinomial. Take the square root of this one and put it here and here. This factor just came down. I want factors of 28, that's numbers that will multiply together to give me 28, and the same numbers will add up to 11. That would be 7 and 4. 7 times 4 is 28, 7 plus 4 is 11. Doesn't matter where we put the 7 and the 4. What matters is they must add up to positive 11. And the only way that can happen is if both of these are positive. Now I've gotten this quadratic equation set equal to 0 and factored. Once I do that, I just employ the zero product property again. I say, well, if this times this times this is 0, then either this one is 0, and it will never be 0 because it's a constant. 7 is a constant. It will never be 0. But this one could be 0 if x is negative 7, or this one could be 0 if x is negative 4. So I'm going to say either x plus 7 is 0, or x plus 4 is 0, and solve both of those. I can't say 7 would be 0 because 7 is 7, but these variable expressions could be equal to 0. So I solve this, and I get x is negative 7, or I solve this one, I get x is equal to negative 4. And I could write my solutions like this. The set whose members are negative 7, negative 4. You'll see your answers written both ways, like this, or like that. Okay, let's take a look at another one. Let me get this stuff over here this way a little bit. Give myself some more room over there. Okay, I want to add 24x to both sides and subtract 80 from both sides to set this equation equal to 0. It's quadratic, so I want to set it equal to 0, factor, and use the zero product property. That's the idea. So I'm going to do this one in my head. I'm going to add 24x to both sides and subtract 80 from both sides. And on this side, it'll look like this. 8x squared. I'm adding 24x to both sides. and I'm subtracting 80 from both sides, equals, and this, when I do that, when I add 24x, this turns to 0, and I subtract 80, this turns to 0. So this whole side turns to 0. I hope I didn't lose anybody when I did that. I added 24x to both sides, so 24x showed up over here, positive. I subtracted 80 from both sides, so that showed up over here as well, negative 80, on this side of the equal sign. And this side of the equal sign, when I did that, turned into 0. Now I'm going to factor this thing and employ the zero product property. So here we go. I notice that this is an 8. The coefficient of my quadratic term is an 8. So I'm going to see if I can divide everything by 8. That's my first effort. So if I pull 8 out of this term, I get x squared, plus, if I pull 8 out of this term, I get 3x, because when I pull something out, I'm dividing each term by whatever it is I'm pulling out. And minus, if I divide this by 8, that'll give me a 10. So I've got it partially factored now. I got 8 times this chunk is equal to 0. Now I'm going to try to factor this. The 8 doesn't go away, although I don't particularly need it, but it is a factor. I take the square root of that one, put it here and here. Factors of 10 that add up to 3. Well, that would be 5 and 2. I can get a 3 if I add or subtract the factors of 10. And one of them is 5 and the other one's a 2. And it doesn't matter where I put the 5 and the 2. What matters is they have to add up to positive 3. And the only way that can happen is if the 5 is positive and the 2 is negative. So now I've got it factored correctly. These multiply together to give me negative 10 and add together to give me negative 3. And I factored the 8 out correctly. You want to be checking these things as you go, because it's easy to make a mistake. And if you make a mistake, just back up and start over again. It's no big deal. Now I'm going to tell myself I need to employ the zero product property. If this times this times this is 0, then either this one is 0, and it will never be because it's 8, and there's no variable there, or this one could be 0, or this one, this factor could be 0. And so I solve the variable equations that could be equal to 0. I subtract 5 from both sides. Here I would add 2 to both sides. So my two solutions would be x is equal to negative 5 or x is equal to 2. And I could write that as the set whose members are negative 5 and positive 2. That's another way of writing the same solution. Okay, and either one of these numbers, if I plug them into this original equation, will make it true. This side will equal this side. So what we're doing is we're solving quadratic equations by setting one side equal to 0, as always, then factoring the quadratic side. And today, we're noticing that each term has a common factor. So we factor it out and then factor the remaining quadratic trinomial as we've done in the past. Then we use the zero product property and find our values that will make the equation true. Let's take a look at a couple more. Here I'm going to just subtract 24x from both sides. I'll go ahead and show it. I don't think I need to show it. This is algebra 2, but I'll go ahead and show it this time. That gives me 4x squared minus 24x is equal to 0. Now I'm going to try to factor this. Whoops, I left off with x, didn't I? 4x squared minus 24x is equal to 0. 24x minus 24x. Okay, now I'm going to try to factor this little quadratic binomial. I see they'll both divide by 4, and I see they both have an x. So I'm going to try pulling a 4 and an x out of both of them. That means I'm going to write down 4x, open a parenthesis, and ask myself, what would be left here if I pulled a 4 and one of the x's out? The other x. And the quick check is just to go ahead and multiply these together and see if you get 4x squared, which we do. Then this minus sign will be there. If I pull a 4 out of this, by dividing, I'm pulling it out, that will leave me with 6. If I pull x out of itself, that gives me x divided by x, which is 1. 6 times 1 is 6. So, whoops, kind of ugly there. Let's see if I can, there we go. And I'm going to check real quick, make sure I've got it factored correctly. 4x times x is 4x squared. 4x times negative 6 is negative 24x. So I have got it factored correctly. Now I'm going to employ the zero product property. If this little chunk times this big chunk is equal to 0, and these little chunks are actually called factors, if this little factor times this big factor is equal to 0, then either this little one is 0, and it could be because that's an x, right? Or this is not a constant, it's a variable term. X plus 6, or rather x minus 6 is equal to 0. And I solve both of them. In order to solve this one, I divide both sides by 4. That gives me x is equal to 0. Or I add 6 to both sides here. X is equal to 6. And unless I've made a mistake, these are the two values such that if I plug them into the original equation, it becomes true. They could be written like this, and they often are. The set whose members are 0 and 6 are the values that will make this original quadratic equation true. I hope I didn't make any mistakes. Okie dokie. Let's take a look at this last one here. Again, I'm going to just set one side equal to 0. I want my quadratic term to remain positive, so I'm going to subtract 100. That turns this into 0, and this gives me 4x squared minus 100. I notice that that is a difference of two perfect squares. Somebody else might say, hey, these both have a factor of 4, and pull that out. And that would work. You'd have 4 times x squared minus 25, which is still a difference of squares. So that's what I'm going to do. I'm going to say, somebody might see this and go, okay, I'm factoring out a 4. X squared minus 25 is equal to 0. Quick check, 4 times x squared is 4x squared, 4 times 25 is 100. And then I hope that they would notice, hey, that's a difference of two perfect squares. That would be 4. To factor a difference of perfect squares, we take the square root of this one, put it here and here. Take the square root of this one and put it here and here. One positive, one negative, and I've gotten it factored. Now I'm going to employ my zero product property. If this factor times this is 0, then one of these three has to be 0, and it can't be this one because it doesn't have a variable. It's not a variable term. That's going to stay a 4. So either this one is 0, x plus 5 is 0, or x minus 5 is 0. And when we solve both of those, subtracting 5 from both sides yields x is negative 5, or adding 5 to both sides, whoops, threw in an extra equal sign in there. I'm getting excited about my equal signs, I guess. Adding 5 to both sides yields x is equal to positive 5. And you could leave your answer like this. Or you could write it like this. And you'll also see it like this. I'll show you one more way that it's often written. Since they're exact opposites, they'll often say the set whose members are positive or negative 5. This means positive or negative 5. And it doesn't matter which order you put them in. All three of these, this, and this, say the exact same thing. X could equal plus or minus 5, positive or negative 5. I hope that makes sense. Again, we're just factoring and employing the quadratic, employing the zero product property. Okay? Well, there we go. Hope it makes sense.